This is upright. I don't have a way to measure the angle, but this is, I'm assuming 90 degree, 90 degree. It's pretty darn close. Anyways, those are some assumptions. And obviously this thing can flex depending on, you know, what's going on. This is, I'm gonna try and make sure that this is folded so that we have a straight line here when we actually have the wind blowing, but that's just an issue with my box. Unfortunately, I didn't make it rectangular because I've got a rounded top of a fan, so that doesn't work, and so my calculations have to do some extra math just to get the area. So that's the downside of this shape, this pentagon shape. Oh, really a polygon. Anyways, measures at 13 on the base. This side is about 8.75 to this corner. See if we can focus in. I mean, oh, I'm pushing down on the carpet. That was my problem. I don't know why. Look closer to 9. Anyways, here it's 8.75 as long as I'm not pushing down on the carpet. And this one, when this is pushed down, I can't remember. I can't push it while I do this, unfortunately. I believe it was 10.5 or something. Anyways, I wrote it all down. This one's 9.5. You can see if I've got this on the correct location. And it's basically the same on the other side, except for this one side. It's slightly longer. It's 9 inches instead of 8.75. Drag this over. Which is perplexing to me, but it just must be due to the duct tape, the way it's lined up, and this side has duct tape. So if I hook this on the bottom, it's really hard to do this with the camera. It comes at 9 inches to that crevice. I think that's probably just due to the duct tape and the fact that these edges are fanned out. This edge has crevices that are filled with duct tape, so that's probably where I got the extra little bit of length. And this side doesn't really have that on this side. The exit dimensions are slightly different because I think that duct tape allowed for a vertical measurement that was greater than the vertical measurement here because there's not the extra room from the duct tape. But this is the only side that's any different from one to the other. My exit volume is therefore a little bit smaller, or my exit area, not volume. And here it is measured out, or well calculated out with my measurements. We got this is the entrance, 13, 9, 10, 9.5, and this is 4.5. I guess I didn't show. I must have. Hopefully I showed that. 4.5. This is the exit. That one's 8.75 instead of the full 9. You notice that's the only difference. So you look over the math real quick. You take this as a rectangle, 13 times 4.5. You take this as an area of a triangle, which this base is 13. The height is the difference between this because we're assuming a nice 90-degree angle as long as I prop it up. And so we use the area for a triangle. 29.5 is the product, the result. And then we have to use, I believe that's what it's called, Heron's formula. Anyways, so I've got 3 sides as long as I do the Pythagorean theorem. I get this side as well, which was 13.829. Well, it's right there. Then S equals this, divided by 2. This is the S value for this formula. Blah, blah, blah. Then we go and input all the appropriate values. Then we get an area of 47.2508 for this triangle section. So I designated the area 1, that's 1. Area 2, that's 2. Area 3, that's 3. So we get for the entrance area is 0.9392 feet squared after you get rid of the inch, after you convert it. And then this one, you get 0.9262 feet squared. So it's a slightly smaller area, which makes sense because we got a slightly smaller dimension on the one side. And that's the entrance and exit dimensions. Now I need to take the velocities. Okay, so my fan, as you can see, the box doesn't quite perfectly cover, or like, I guess, fit it. That's the way I'd say that. I'm gonna just record the readings and then look over them. Oh, make my batteries dying. See if they can focus or not. Okay. Let's take a reading here. Looks like 1.6 all the way over in this bottom corner. Actually, 1.7. 1.7 is probably a better reading. It seems to stay there longer. We'll take one in this corner. That's 2.0, 1.9. We'll say 2.0 since that seems to be the average. We'll take one up in this pocket, 1.9, 2.0. Okay. We'll take one up in this pocket. That is 2.1. Now let's take one about here. That's 2.0. We'll take one here. That is 2.0 as well. And then we'll take one in this dead spot. This is 1.4, which is roughly the center of this area. And then we'll take one at the bottom below the center. It's also 2.2. 2.2, yeah. Okay, so now we'll go look at the exit, see what kind of velocities we get in each one of these areas. Well, that is not very high. That's 0.6 in this bottom corner. We'll take one right here. That is 1.4. It keeps changing. There must be turbulence through this. 1.5. And then it drops down to 1.0. Now it's back down again. That's interesting. Quite the variance in that. Up here we get a lot more speed. Can't see that, but it's 3.1, 3.2. In this we get 2.9, 3.0. And then it fluctuates and it dips down to 2.4. But it keeps coming back to 2.9, 3.0. It just peaked at 3.3. Okay. Now let's go here. Down in this corner we get 0.5, 0.4. Now it like sometimes it stops completely. That's interesting. Peaks at 0.4 and then goes back down to basically 0. 0.1. Okay, now directly in the middle, bottom middle, we get 0.4, 0.6. 0.6 seems to be better. That's a 0.9. 0.9 seems pretty more consistent. Okay, smack in roughly the middle, we get 2.6. Now it's up to 3.0, 2.9, 3.0. I got too much variance. Left of center we get 2.5. Right of center we get 2.5. I'm gonna record this because I don't think I got a measurement for right here. I would have thought I did, but it's 2.1. Goes from 2.2 down to 2.0 and then comes to 2.1, so we'll take the average. Entrance velocity, take my average, you get 6.378 feet per second. Exit velocity, average is 6.1614. Here's the formulas. Here's my air temperature of my room. This is my density of the air. The Q equals my A, my area, times my V, which was my average velocity. My average velocity. You get Q equals 5.9902 feet cubed per second. Similar over here, we get 5.7067 feet cubed per second. So that was my volume and entrance and exit. Entrance mass flow, times it by my mass, we get 0.4394. On this, we get 0.4186 pounds per second. The cubic feet cancel out. So my volume loss is 0.2835 cubic feet per second, and my mass loss is 0.0208 pounds per second.